Hello, student. Welcome back to this chapter of optical fibers. And in this session, we are going to study the types of optical fibers. So, there are three types of optical fibers depending on the refractive index profile. What is this refractive index profile? It is the curve which represents the variation of refractive index with respect to the radial distance from the axis of the fiber, and this is called as the refractive index profile. That means as you are coming outside from the axis of a cable radially, the refractive index of the cable optical fiber changes, and how it changes, that is called as the refractive index profile. On the basis of this refractive index profile, the optical fibers are classified into three categories, namely step index single mode fiber, step index multimode fiber, graded index multimode fiber. So these are the three types of optical fibers. So one is the step index single mode fiber, second one is the step index multimode fiber, and third one is the graded index multimode fiber. So these are the pictures of these three types of optical fibers. So at the bottom is the single mode step index fiber. So why it is called so? Because it offers, or it supports only one mode of propagation of the wave. So that is why this is called as the single mode step index fiber. And why it is called as a step index fiber? Here I have shown the refractive index profile of this cable. You can see this curve of the variation of refractive index with the radial distance from the cable axis. Make a step here, a step, it takes a step type of structure. Here it is a step formation is there. So because of this reason, this is called as the step index single mode fiber. And middle one is the multi-mode graded index fiber. So this is called as the multi-mode because of its a wider diameter, core diameter. It supports a large number of propagation modes of the light signals, and because of that reason, this is called as the multi-mode fiber. And you can see many forms of the propagation of the signals inside the cable. And this is called as the grade index cable because you can see here the refractive index profile of this fiber is not taking a shape of step. Instead of that, it is gradually changing. When one moves from core to cladding, it gradually moves. So from the axis of this cable, when you are moving away from the axis of this cable radially, you can see here the refractive index is gradually decreasing inside the core. But when it touches the cladding, again here the line is going up straight away. That indicates that uh, inside the cladding, the refractive index is not going to change. It is uniform. The refractive index is changing only inside the core material. So such a cable, such a fiber is called as the multi-mode graded index fiber. This is another one multi-mode step index fiber. So this is also called as the multi-mode fiber because it is also having the wider diameters, and because of that reason it supports the many mode of propagation of the light rays, and hence it is called as the multi-mode fiber. And this is a step index fiber because when you look at the refractive index profile of this cable, this is taking the shape of a step again, like the single mode step index fiber, and because of this reason this is called as a step index fiber. And another, and this N1 and N2 indicate the refractive index of core and cladding. And one more thing here is that what you are looking at here is the shape of the input pulse. This is the shape of the input pulse, and this is the shape of the output pulse. So as you are moving up towards the multi-mode step index fiber, it is very clear that the width of the output pulse becomes so wider and wider. So yeah, the width of the output pulse is widening here. So same thing I will explain here once again. So this is the step index single mode fiber. In a single mode fiber, both core and cladding have uniform refractive index, but refractive index of core is slightly greater than that of the cladding. Thus, refractive index profile takes the shape of a step. The diameter value of the core is about 8 to 10 micrometer. So it is very small. And because of this reason, it doesn't support the more number of modes of propagation. And the external diameter of the cladding is 60 to 70 micrometer. Because of its narrow core, it can guide just a single mode. Hence, it is called a single mode fiber. And the single mode fibers are the most extensively used ones, and they constitute 80% of all the fibers that are manufactured in the world today. They need laser as the source of light. These are less expensive but very difficult to splicing. Splicing means connecting the two fibers. This fiber has a yellow colored outer jacket. So by looking at just the color of the outer jacket, we can decide what type of fiber it is. So this is about step index single mode fiber. So about the step index multi-mode fiber here, in case of step index multi-mode fiber, core has a diameter of 50 to 200 micrometer, and cladding diameter is around 100 to 250 micrometer. So because of this wide diameter of the core, which ranges from 50 to 200 micrometer, this fiber supports the propagation of more number of waves or signals, and because of that reason this is called as the multimode fiber. Because of wider diameter of the core, it is able to support propagation of large number of modes. The refractive index profile of this fiber also takes the shape of a step, and hence this is called as a step index multimode fiber. The step index multimode fiber can accept either a laser or an LED, that is light emitting diode, as a source of light. It is the least expensive of all. Its typical application is in data links, which has lower bandwidth requirements. This fiber has an orange color jacket. Next, we will move to the graded index multimode fiber. As I have already explained in the diagram, graded index multimode fiber is also denoted as a green. This is simply called as a green, graded index multimode fiber. The geometry of the green is same as that of the step index multimode fiber. The refractive index of the core decreases radially in the outward direction from the axis and becomes equal to that of the cladding at the interface, and because of this reason it is called as a graded index of fiber. But the refractive index of the cladding remains uniform, and uh, because of the continuously varying refractive index across the core, the light rays are bent smoothly and converge repeatedly at the points along the axis of the cable. The light rays near the edge of the core take a longer path but travel faster, since the refractive index is lower. So this green it supports either laser or LED as a source of light. So any one of these two can be used as a source of light for the green, and it is the most expensive of all because the production cost increases because the refractive index of the core is gradually changing when you are coming out of the axis directly or radially. So that leads to the increase of manufacturing cost. Its splicing could be done with some difficulty. Its typical applications is in the telephone trunk between central offices. The outer jacket of the green will be having lime or aqua color. So this is about graded index multimode fiber. Next, we will see what is the coherent bundle. So if a large number of fibers are put together, it forms a bundle. So if a large number of fibers are put together, it forms a bundle. A bundle may consist of thousands of individual fibers with a diameter in the range 0.0002 centimeter to 0.001 centimeter. So the diameter of the individual fiber is very, very small. If the fibers are aligned properly, that is, if the relative positions of the fibers in the input and output ends are the same, the bundle is said to form a coherent bundle. So this is very, very important. That means the relative positions of the fibers at the input end and at the output end should be same. Then it is called as a coherent bundle. If a fiber is eliminated at one end, a bright spot will be formed at the other end. Thus, a coherent bundle transmits an image from one end to another. So, this coherent bundle is used to transmit the image from one place to another. That is the use of this coherent bundle. So this coherent bundle has an advantage of flexibility. The most important application of a coherent bundle is a fiber optic endoscope, where it can be put inside a human body, and the interior of the body can be viewed from outside. So for the manufacture of endoscope, an instrument which is used to see the inner parts of our body, this coherent bundle is used. A state-of-the-art fibroscope can have about 10,000 fibers, which form a bundle of about 1 mm in diameter and capable of resolving objects as up to 70 micrometer across. And fiber optic bundles can also be used for viewing parts of a machine which are otherwise inaccessible. So that is another advantage or the application of this coherent bundle. So this is about numerical aperture and ray propagation, and this is a derivation part I will go through in the next session. Thanks for listening.